Welcome to today's lesson, students. So, I'm going to continue with the extra questions of Unit 9, Heat. So, this is extra question 31. What is the quantity of heat absorbed by a block of copper of mass 2 kg to rise in temperature from 30 degrees Celsius to 50 degrees Celsius? So, as we do normally, mass is 2 kilograms. And you can see temperature changes from 30 degrees Celsius to 50 degrees Celsius. And the specific heat capacity of copper is given to you as 400 joule per kilogram per degrees Celsius. So, what is it we need to calculate? What is the quantity of heat? So, here what is the quantity of heat absorbed by a block of copper of mass 2 kilogram? So, students, you all know what the equation is. Q equals mc theta. That is what we need to use. Q equals mc theta. What is m? 2 kilogram given in the standard unit. So, no need to change. Then we have the specific heat capacity 400 joule per kilogram per degrees Celsius. Then what is the temperature change? That is theta. That is going to be 50 minus 30 degrees Celsius. So then if we simplify that, we can cancel off certain values. You know that kilogram minus 1, then degree Celsius minus 1 and degree Celsius. So you will have the values as 2 into 400 into 50 minus 30, 20. And the unit will be in joules. So, here of course, we can easily calculate it. 2 into 400, 800. 800 into 20, it will become 16,000. We have 3 zeros, then 4, 8 into 2, 16. So, this is going to be 16,000 joules. So, that is the quantity of heat absorbed by a block of copper of mass 2 kilograms to rise in temperature from 30 degrees Celsius to 50 degrees Celsius. So, that is a direct calculation. I am sure, students, you also did this calculation correctly. So, with that, I will move on to the next question. Extra question 32. 4 spoons made of different materials with the same shape and size were placed in a bowl as shown in the diagram. So, you can see here, students, the diagram is given to you. It is said that the spoons have the same shape and the size. So, they are all identical except the material that they are made up of. So, here you can see it is a plastic material. Then there is stainless steel. Then there is silver and wood. You know, stainless steel is an alloy of iron. Iron with different substances, different elements. You form the stainless steel alloy. And silver is a metal, whereas wood and plastic, you know what they are. So, 4 different materials, and you can see here there is the temperature mentioned as 95 degrees Celsius. We will see why. Water at 95 degrees Celsius poured into the bowl. Answer the questions based on the observations. So, the water was poured into the bowl, that is at 95 degrees Celsius. Then you all know what will happen. The water is at high temperature, whereas the spoons will be at room temperature. So, there is a temperature difference. Then what happens? Heat transfers from high temperature to low temperature. So, from water, the spoons will have to absorb heat. But that will depend on their nature. The materials that can absorb and conduct heat well, they will absorb more heat. That means their specific heat capacity will be usually less. Whereas substances which have a very high specific heat capacity or the ones that do not conduct heat, they will not absorb and conduct heat. So, that is what you can observe from this activity. I am sure you all can understand that. So, now we will look at the questions. The first one, which spoons get hot faster? So, out of the 4, plastic, stainless steel, silver and wood, what do you think becomes hot faster? Both stainless steel and silver. And out of those also, silver becomes hot very fast compared to stainless steel. Normally, iron takes a long time. Iron or alloys made up of iron, they take a longer time to become hot compared to other metals like silver, aluminium and copper. Which spoons get hot faster? It is silver and stainless steel. So, silver and stainless steel. So, then we have the second question. Classify the types of spoons into two groups based on the observations. So, here you can understand, students, stainless steel and silver, they are good conductors of heat, so they become hot faster. Whereas plastic and wood, what do we call them? They are insulators because they don't conduct heat well, or they don't conduct heat at all. So, that is why they are insulators. So, that is the two groups, or that is how we classify them into two groups. So, here we can say conductors, again silver and stainless steel. Then we have insulators, that is plastic and wood. So, out of this, we have classified the spoons into two groups. Classify the types of spoons into two groups based on the observation. So, this is how we classify them. Then we have the third question. What is the mode of heat transfer in the silver spoon? So, silver is a metal, a solid. In solids and metals, what is the mode of heat transfer? It is conduction. So, the answer here is conduction. Conduction of heat. So, then I will move on to the next question. Explain the method of heat transfer you mentioned above. So, you all are familiar with conduction. How does this happen? When you supply heat to one end of a solid, there are atoms that can vibrate. The atoms at the end where heat is supplied, they become hot. Therefore, the kinetic energy, that is the mean kinetic energy, increases. They start vibrating faster. Because of that, they collide with the adjacent atoms. So, due to vibration, higher vibration and collision of constituent particles or atoms, heat is conducted from one end to the other end of the solid. So, that is the conduction process. That is what you have to explain here. When heat is supplied to one end of a solid, the particles absorb energy. Therefore, the kinetic energy of those particles, or you can say atoms, increase and make them to vibrate faster. This increases collision between the atoms, or you can say particles conducting the heat energy from one end to the other. So that is the process of conduction. So when heat is supplied to one end of a solid, the particles absorb energy. Therefore, the kinetic energy or kinetic energy of those particles or atoms increase and make them to vibrate faster. So, you know, students, when we describe the substance, a solid substance, you can call them as the atoms or the constituent particles. So, then you can see this increases the collision between the atoms or particles conducting the heat energy from one end to the other. So, when particles vibrate and collide with each other, heat is transferred from one particle to the other. So, in that way, heat is transferred from one end to the other end. That is what we call as conduction of heat. So, I am sure you were able to explain this clearly. Then the next question. Why is the method mentioned above efficient in the stainless steel and silver spoon? Why is it more efficient? So, these stainless steel and silver, they are either metals. Silver is a metal, stainless steel is an alloy of metals. So, you know they exist in the lattice form, metallic lattices. And in the metallic lattices, what is there? The nucleus, that is the positively charged atoms, as well as the free electrons. So, in metals, both the atoms and the free electrons can vibrate and they can transfer or conduct heat. So, therefore, it is even more efficient and faster for the metals to conduct heat. So, that is the answer you have to write here. Why is the method mentioned above efficient in the stainless steel and silver spoons? So, we can say stainless steel, and silver are made of metallic lattice that contains atoms and free electrons. Both vibrate and conduct heat. Therefore, conduction is more efficient in metals and alloys of metals. So, that is how you can explain it. Stainless steel and silver are made up of metallic lattice that contains atoms and free electrons. Both vibrate and conduct heat. Therefore, conduction is more efficient in metals and alloys of metals. Silver is a metal, stainless steel is an alloy of metal. So, that gives the explanation. So, I am sure students, you also understood the question well and you have answered it in the correct manner. So, with that, I will move on to the next question. Extra question 33. Aluminium vessel of mass 2 kg contains 1.5 kg of water at 50 degrees Celsius. So, if you show that in a diagram, this is an aluminium vessel. So, aluminium vessel, the mass is 2 kg and it has water and the mass is 1.5 kg. Then you can see the temperature is 50 degrees Celsius. Calculate the heat required to increase the temperature of water to its boiling point. So, from 50 degrees Celsius, we need to increase the temperature to 100 degrees Celsius. Specific heat capacity of water and aluminium are 4200 joule per kilogram per degree Celsius and 900 joule per kilogram per degrees Celsius respectively. So, the specific heat capacities you all know is different and the two values are given to us. So, then what do we need to do? We need to find the heat. Calculate the heat required to increase the temperature from 50 degrees to 100 degrees Celsius. We have discussed similar questions before even in your lesson. You can remember we need to calculate the heat absorbed by water and the heat absorbed by the vessel separately, and then we need to add them together. So, same equation, Q equals mc theta. So, then if we calculate heat absorbed by vessel, that is equal to 2 kg into, you can remember, or you know the value is given to you, 900 joule per kilogram per degrees Celsius. And the change in temperature from 50 degrees, it has to come to 100 degrees. So, 100 minus 50 degrees Celsius. Then, it's easy to simplify, can cancel off kilogram and kilogram minus 1, degree Celsius, degree Celsius. So, we will get the value as 2 into 900 into 50 joules. So, for convenience, if I multiply 2 into 50, so there are 900 into 2 into 50 is 100 joules. So, that means it will be 90,000 joules. So, that is the heat absorbed by the vessel. Then, if we calculate the heat absorbed by water, heat absorbed by water. So, that is equal to, you can remember, there was 1.5 kilogram of water and the specific heat capacity, I am sure you can remember, and it's given here 4200 joule per kilogram per degree Celsius. So, if we calculate that 1.5 kilogram into 4200 joule per kilogram per degree Celsius. Here we have already calculated the change in temperature 50 degrees Celsius. So, you can simplify easily, kilogram, kilogram minus 1, degree Celsius minus 1, degree Celsius. So, then we can rewrite the values 15 into 4200 into 5 joules. So, if I find the final answer, I will do the calculation here. 4200 into 5, that is going to be 21,000. Then if we multiply that by 15, then we have 0,005 and 10. Then when you multiply by 1, you have 1 and 2. So, if we add them together, 0,005, 1, 3, 315,000. So, here the value is 315,000 joules. Then initially we had 90,000 joules. Now it is to 315,000 joules. Heat absorbed by water. We need to add them together. So here heat needed to increase the temperature of water to its boiling point is equal to 90,000 joules plus 315,000 joules. When you add them together, you will get the value as 405,000 joules. 315 plus 90,000, 405,000 joules. So I am sure you would have done the calculation correctly. Just we will go back and check. So here you can see initially there is water at 50 degrees Celsius in an aluminium vessel. The weight of aluminium, repeat, the mass of aluminium is 2 kilograms, water is 1.5 kilograms. The specific heat capacities are given. So if we calculate the heat absorbed by the vessel, 2 kilogram into 900 into 100 minus 50. So 2 into 900 into 50, then it becomes 900 into 100, 90,000 joules. Then heat absorbed by water is 1.5 kilogram into 4,200 into 50. So you get the values as 15 into 4,200 into 5. I simplified the 1.5 and 50 there so that it's easy for us to do the calculation. Then if you calculate the value, you get the answer as 315,000 joules. So heat needed to increase the temperature of water to its boiling point, 90,000 joules plus 315,000 joules. That gives you a value of 405,000 joules. So I am sure students, you were also able to do this calculation correctly. With that, I will move on to the next question. Extra question 34. Write an application each for thermal expansion in solids, liquids and gases. So you all know what thermal expansion is. When you supply heat to a substance, a material, the volume or the area or the length increases. That is what we call as thermal expansion. So that occurs in solids, liquids and gases, and you are familiar with the different applications. When there is thermal expansion in solids, what is the application? Now here they have, yes, asked for applications. You all can remember the bimetallic strip. So bimetallic strips, when there is thermal expansion, one metal expands less, the other metal expands more, so that it is used to regulate the temperature in an electrical appliance. So that is a function of bimetallic strip. Then there are many other functions that we have discussed before. Even to insert a nail into a small hole, a metal plate with a small hole. If you want to insert a nail, then what do? You heat the nail. Then with that temperature, when you try to push the nail through the metallic plate, the hole expands a little bit, the nail goes through. Then when it is allowed to cool down, it fits well with the metallic plate. The same way, riveting of two metals, that is also done using the thermal expansion. So those are all different applications. And you know, in our environment, there are other observations that you see in the environment that are related to thermal expansion seen in solids. The rails of the railway track, there is a gap between the rails. Why? When the rails expand due to heat, they will fill up the space so that the railway track does not change in shape. It will remain the same even during high temperature. The same way, telephone cables, electricity cables, they are normally loose. They hang a little bit. so that during the daytime there's no problem, they'll be hanging, but during the night time when the temperature drops, they will contract, but they will not break off from the post. So those are all different instances where you see applications of thermal expansion in solid. So here they want you to write just one application of thermal expansion in solids. Even another example that we have discussed, fixing the metal rim to the wooden bullock cart, the cart wheel. So that also uses thermal expansion in solids. You all know the metal rim is made a little smaller than the diameter of the wooden cart wheel, so that when you heat the metal ring, it expands. You can insert the wooden cart wheel into it, and when the metal ring is allowed to cool, it fixes with the wooden cart wheel very strongly so that it doesn't come off while the wheel is moving. So that is again an application of expansion in solids. So we can write any one of those examples. I will write the one with the cart wheel. So we can say in solids, fixing the metal rim to the wooden cart wheel. Then in liquids, that's a very common application. We use mercury and alcohol in glass mercury thermometer as well as glass alcohol thermometer. So there we are able to use those two liquids because of their thermal expansion. That's why we are able to read the temperature. The same way, students, I did mention even solids, expansion of solids, the bimetallic plate, it is used as the thermostat. That is also a thermometer. So there also it is the expansion in solids due to temperature. So here if we write for liquids, mercury and alcohol used in glass thermometers. So then we have the next one, expansion in gases. In gases, if you can remember, students, the two natural phenomenon where there is thermal expansion, that is sea breeze and land breeze. And also in addition to that, you all can remember, students, the hot air balloons. So there again, when there is heat absorption due to heat absorbed by the air expands. That is why the density decreases and air rises up. The hot air rises up. Along with that, the hot air balloon also rises up. So that is an example for expansion of gases. So you can either write sea breeze and land breeze, or the using of sea breeze and land breeze. We have discussed that before also. The fishermen use sea breeze and land breeze. Sea breeze to come back from the sea to the land, and land breeze to go from the land to the sea. So use of sea breeze and land breeze by fishermen. That can be written as an application. I will write that here. Use of sea breeze and land breeze by fishermen to travel in boats towards the land and sea respectively. So their sea breeze helps the fishermen to travel from the sea towards the land, and land breeze helps them to travel from the land to the sea. So these are all applications of thermal expansion in solids, liquids and gases. So in solids, fixing the metal rim to the wooden cartwheel. Then in liquids, mercury and alcohol used in glass thermometers. Then gases, use of sea breeze and land breeze by fishermen to travel in boats towards the land and the sea respectively. Then we have the next question. The part 2, write an application of bimetallic plates. So you are familiar with bimetallic plates. There are two metals with different thermal expansion. So one expands less, the other one expands more. Because of that, the bimetallic plate or the strip, it curves. So using that, we can connect and disconnect the circuit in an appliance where heat is produced. So that is to regulate the temperature of a device where heat is generated. For example, in irons, electric kettles, even in rice cookers, we can use all these. Even electric toasters, we use the bimetallic strip. So that is what you need to write here. Write an application of bimetallic strip plates. So here we can say it is used to regulate temperature in devices that produce heat, or we can say device in which electric energy is converted to heat energy. Heat energy. So it is used to regulate temperature in devices that produce heat or device in which electric energy is converted to heat energy. So as examples, we can write electric iron, then we can say electric toaster, rice cooker. These are a few examples. So electric iron, electric toaster, rice cooker. So that is how we use bimetallic plates in different appliances. It is used to regulate temperature in devices. So with that, students, I will move on to the next question. Extra question 35. Scientifically explain the following observations from your environment. There is small gap between rails of the railway tracks. And the second one, telephone wires and electricity cables are almost straight and tight between the posts during night time and loosely hang during the daytime. So we need to explain these two observations. The first one, I just explained that to you all in the previous slide also. What happens when there are rails, there is a gap between them. Why? The metal of the rail expands due to heat, that is the high temperature during the daytime. So if it was a continuous track, due to expansion, it will become deformed. But when there is a gap, when the rails expand, they will expand and fill up that space. So there will be no change in the shape of the railway track. So that will allow the train to pass through without any problem. So that is why there is a gap. If you are to write it as a short answer, we can say that is to have space for the expansion of rails during daytime due to high temperature. That is the reason why there is small gap between rails of the railway tracks. Then the second one, telephone wires and electricity cables are almost straight and tight between the posts during night time and loosely hang during the daytime. What is the reason? During night time, there is contraction in the cables due to decrease in the environment temperature. But during daytime, the wires and cables expand due to the higher environment temperature. So that is how we can explain this observation. During night time, there is contraction in the cables due to decrease in the environment temperature. But during daytime, the wires and cables expand due to the higher environment temperature. So because of that, you can see this observation. They are tight and almost straight between the posts, whereas during the daytime, they will be loosely hanging. So with that, students, I will move on to the next question. Extra question 36. So here there is a diagram given to you. I'm sure you are familiar with this activity. We have done this in the lab. Apparatus used to illustrate the expansion of liquids is given below. So a test tube was filled with colored water. A rubber stopper with a glass tube was fixed to the test tube. The water level in the glass tube was marked as A. The glass tube was inserted into a vessel containing warm water for a few minutes. The change in water level in the glass tube was observed. So you can see here there is a stand where the glass tube is fixed, and inside that there's colored water, and inside that there is another glass tube that is inserted into a vessel containing water, and heat is provided. So from point A, you can see the change in water levels. So what is the first question? Why does the water level in the glass tube go down initially? You have observed this, you know the reason. Why does that happen? Initially, the glass tube expands, but the water takes a longer time to expand. So because of that, because the glass tube increases in volume or it expands, the water level drops down. That is the first observation. So here we can say initially the glass tube expands due to heat. Therefore, the water level drops. So we can say water level drops. That is the reason, because the expansion of glass. Then I will move on to the next question. Why does the water level in the glass tube rise again after going down? So there what happens? After some time, water also absorbs heat and it starts to expand. Why does it start expanding late? Because the specific heat capacity of glass is somewhat less. So glass absorbs heat fast, it expands quickly, and then water absorbs heat and it starts to expand. So at the point where the expansion of water is more than the expansion of glass, the water level rises up in the glass tube. So that is what you have to write here. When the expansion in water is more than glass, the water level glass, you can observe the water level increasing in the glass tube. So that is what happens there. Then we have the next question. What can you conclude from this activity? So this activity was carried out to observe that the water or liquids expand on heating. So that is what we can conclude from this activity. When heat is provided to a liquid, it undergoes thermal expansion. So we can write that. When heat is supplied to a liquid, it undergoes thermal expansion. Or in other words, you can say the volume of a liquid increases when heat is applied to it. That is what we call as expansion or thermal expansion. So I am sure students you were able to answer these questions correctly. I will move on to the next question. Extra question 37. A small amount of potassium permanganate crystals was wrapped in a polythene pouch and was placed inside a vessel. Water was taken into the vessel and heat was supplied as shown in the diagram. So here you can see students, we have done this activity in the lab. So you're familiar with this activity. This is potassium permanganate, KMnO4, or what we call as Condis, you know that. And then there is water there. We supply heat to this potassium permanganate. Why do we wrap it in polythene pouch? So that little by little the potassium permanganate dissolves in water so that you can see the observation clearly. So you know what will happen there. We will look at the questions given. What will be the observation of this activity? What will you all observe? You will see the circular movement of purple color. Starting from here, the purple color will rise up and then it will spread throughout the water. So that is what you will see here. So you can say the purple color spreading upwards and then undergoing the circular movement in water. That is what you will observe. Then the second one. Explain why you get that observation. What is the reason? Heat is transferred by convection in water. So due to convection currents, the hot particles rising up and the cool particles moving downwards, we see that above observation. So the reason, explain why you get that observation. Heat is transferred by convection in water. Movement of purple color. Purple color indicates the convection current. So explain why you get the observation. Heat is transferred by convection in water. Movement of purple color indicates the convection current. So if they ask you to explain it in detail, you can explain the convection process as well. What is the name given to the process that is illustrated by this activity? We have already written the name. It is convection. Convection in liquids. That is the process. So I am sure students, you were also able to answer these questions correctly. With that, I will move on to the next one. Extra question 38. Why do the leaves and branches of a tree tend to swing when there is a fire lighted under it? You can remember this observation, students. If you have a tree like that and if there is fire burning there, you can see the leaves here moving. So why is that? Due to fire, the particles, air particles around it become hot. They expand, the density decreases. Because of that, the air particles move upward. That is what we call as convection. And the cool air particles tend to move down. The movement of these air particles make the leaves and branches to move, sway here and there. That is the reason. So here, why do the leaves and branches of tree tend to swing? So we can say, when there is a fire under the tree, the air particles around it become hot and expand. Therefore, their density decreases, making the particles to move up. The cooler particles of air move downwards. Move downwards. This movement in air causes the leaves and branches to swing. So that is what happens. When there is a fire under the tree, the air particles around it become hot and expand. Therefore, their density decreases, making the particles to move up. The cooler particles of air move downwards. This movement in air causes the leaves and branches to swing. So, I am sure students, you were able to write a similar answer explaining the observation. With that, I will move on to the next slide. Extra question 39. Equal volume of water was taken into two identical glass vessels. Immersion heaters were inserted into the vessels as shown in the diagram. So here you can see glass vessels X and Y. There are immersion heaters inserted into water. You can see the shape, the size, everything is the same and there is equal volume of water. What is the difference? In X, the immersion heater is at a higher level. In Y, the immersion heater has been inserted right to the bottom of the vessel. That's the only difference. So the questions, you're familiar with that observation, students? We will answer the questions related to that. In which vessel does water boil faster? I'm sure you all know the answer. What is it? In vessel Y. So it is vessel Y. What is the reason for your answer in part 1 above? In vessel Y, the immersion heater is right at the bottom. So all the water gets heated up and heat is transferred easily by convection. Therefore, it boils faster, or yes, it boils faster. So there we can say in Y, the heater is at the bottom and water gets heated by convection from bottom to top. This leads to faster boiling. But you can see in X, the heater is partially immersed, or it is immersed to only the middle of the vessel. So that leads to slower boiling. So here, what is the reason for your answer in part 1? This is the reason. So from bottom to top, the water becomes hot very fast. So that is what we need to write here. Then the next question. there is 1.5 kilogram of water at 27 degrees Celsius in the vessel you mentioned in part 1 above. Calculate the heat that needs to be supplied by the immersion heater to increase the temperature to 97 degrees Celsius. Specific heat capacity of water is given to you as 4200 joule per kilogram per degree Celsius. So you are familiar with this type of calculation. Heat is Q, that is equal to mc theta. We have done many calculations similar to this. Heat absorbed or heat needs to be provided to water is equal to mc theta. What is m? Mass of water, that is 1.5 kilogram. What is the specific heat capacity? 4200 joules per kilogram per degrees Celsius. And what is the change in temperature? From 27 degrees, it increases to 97 degrees. So 97 minus 27 degrees Celsius. So here, if we write the answer, 15 into 420 and kilogram minus 1, degree Celsius and degree Celsius. And I have simplified the decimal with the 0. So then you have 97 minus 27, 70 degrees Celsius. So that is joules. The unit will be in joules. If we multiply and get the value there, 420 into 15, that is going to be 0, 10, 21, 0, 0, then 2, 4. So we get the answer as 3, 6. 6,300 into 70. We need to multiply by 70. So 0, 0, 0, 20. 3 into 7, 21. 2, 7 into 6, 42, 44. 441,000 joules. So the answer here is going to be 441,000 joules. That is the amount of heat that needs to be supplied by the immersion heater to increase the temperature to 97 degrees Celsius. So I am sure students, you were also able to answer this question correctly. You would have done the calculation correctly. So with that, I will move on to the next question. Extra question 40. Why do you use Thermos flask? Why do you use Thermos flask? To store hot liquids or cold liquids. So that is what you have to write here. To store hot or cold liquids and maintain their temperature. Then the second one. Before we go to the second question, students, you can see the picture here. That is the picture of a diagram where you see the thermos flask. You can see there is a lid there. Then there is the thermos area. That is this one. In that there is hot water. And you can see the silver colored inner wall and the vacuum space between the two walls as well as the external casing. So you are familiar with this structure. Then if we look at the second question, how is heat loss by conduction prevented in the thermos flask? How is that prevented? By having a vacuum between the inner and the outer walls. So that is what you need to write. By having a vacuum between the inner and outer walls of the thermos flask. So then we have the third question. What is the advantage of having a vacuum between the two glass walls of the thermos? So again, we have answered a similar question. Why? To prevent heat loss by conduction. So the same technique used in the thermos class, they can ask the question in different ways. So that is what is given to you here. So here we have to say to prevent heat loss by conduction. Then the fourth question, why is the inner wall of the thermos shiny? Why is the inner wall of the glass thermos shiny? So that it can reflect the heat radiated back into the liquid. So here you can see, because heat radiation can be lost through vacuum also. To prevent that, the heat radiation has to be reflected back into the liquid. So here you can say heat can be radiated through vacuum. To prevent this, the inner wall is made shiny so that the heat radiation is reflected back into the liquid. So by doing that, we prevent heat loss by radiation. So I am sure students, you were able to explain this clearly. With that, I will move on to the next slide. There we have extra question 41. Again, from the diagram, you all know what this activity is. A metal cube that is at higher temperature is put into water at room temperature, and you observe the thermometer reading, how it increases. This is to show how heat transfer takes place and how thermal equilibrium is reached. So the question, a heated piece of iron was put into a vessel containing cold water and the temperature of the water recorded. What is the observation of this activity? What will you see? Increase in the reading of the thermometer. Increase in the reading of the thermometer. Then the second question, how would you explain the change in the thermometer reading? So it will increase first and it will reach a fixed point. So that also can be included here. Then it becomes stable. So how would you explain the change in the thermometer reading? Initially, heat is lost by the iron to water. So here we can say initially heat is transferred from the piece of iron to water. Therefore, the temperature of water increases until thermal equilibrium is reached. Or students, you can say until the temperature of water and the piece of iron become equal. So then we have the third question here. After a while, the temperatures of the water and the iron block become equal. So we have already discussed that above. After reaching this common temperature, heat does not flow to the water from the iron block or to the iron block from the water. What is the name given to this state? We call it the thermal equilibrium. So thermal equilibrium. We have mentioned this term in our explanation also. So the first question, what is the observation of this activity? Increase in the reading of the thermometer. Then it becomes stable. You can omit that part also, but you have to write that there is an increase in temperature. Then how would you explain the change in the thermometer reading? Initially heat is transferred from the piece of iron to water. Therefore, the temperature of water increases until thermal equilibrium is reached, and then the name of the state is again thermal equilibrium. So I am sure students you were able to understand this activity and answer these questions correctly. With that, I will move on to the last question. What is transfer of heat? What is it? Flow of heat energy or thermal energy from high temperature to low temperature. So we can say flow of thermal energy from high temperature from an object with high temperature to an object with low temperature. Temperature when in contact. So the object with high temperature and object with low temperature have to be in contact with each other. Then there will be a flow of thermal energy. That is what we call as transfer of heat. So then the last question, students. What is the standard international unit of measuring heat? What is the standard international unit of measuring heat? It is joules. So we can write the symbol as joules. If you like, you can write it in brackets as joules also. So what is the standard international unit of measuring heat? That is joules. So with that, students, I have completed the extra questions in this lesson. So I am sure, students, we started off the lesson with what temperature is, then we discussed what thermometers are, then we discussed what heat is, specific heat capacity, how heat transfer takes place, thermal expansion, how heat is transferred from one place to the other, different methods, conduction, convection and radiation. So thereafter, we saw how we can calculate the heat absorbed or released by objects using the equation Q equals mc theta. So with that, students, we discussed the questions from your textbook as well as a lot of extra questions. So I am sure now you have a very good understanding about this lesson, heat.